Okay. Hi guys, can you hear me? Mahinder, Krishna, Pankaj,
Yeah, sure.
Rangaraju, Veeraprasad.
Yeah, sure.
Hey guys, good evening. Okay, so yeah, let's get started without any further ado. Let me share my screen and record this session as well. Right. So as discussed yesterday, today will be the first class on the topic networking fundamentals, a very important prerequisite for cybersecurity. Now, when you talk about networking, there are three important definitions to know or come across. What is networking? What are networks? And what are hosts? Okay. So when you talk about networking, this is the practice of connecting information devices with each other. So in an organization, you have all sorts of devices. You have firewalls, you have routers, you have switches, you have client operating system devices, Windows 10, Windows 11 based devices. You have server based devices, okay, Ubuntu servers or Linux servers or Windows servers. Yeah. Different categories of servers again. DNS servers, DHCP servers, FTP servers, whatnot. So in an organization, we have all these devices. There is a need for connectivity among them. Okay, you need to share or again, I would say, get or send data from one device to the other device and these resources as well. Okay, so the process of connecting these devices with each other so that they can share resources and transmit data is called as networking. Okay, and the collection of those interconnected devices or that group of those interconnected devices is as a whole called as a network. Okay, and each individual device in that network is called as a host. It's referred to as a host. So your computers, your printers, your routers, mobile phones, whatnot, any information system which is capable of receiving data and sending back data, transmitting data, is basically called as a host. Now, just like how we humans have a respective name to address each other or to recognize each other, these devices also have their own names. And those names are called as IP addresses. This IP word stands for Internet Protocol. Built by the US military in the late 1950s or so, there were multiple experimental versions for it. There was IP version 1, IP version 2, IP version 3 that was not released to the public. What successfully worked out was IPv4, and that was released. Okay. And even in today's world, we still use IPv4 addresses. Okay. So to define an IP address or Internet Protocol address, each device or each host on a network has a unique identifier. That unique identifier to give the identity or to give the recognition for each system is called as an IP address. Okay. And these IP addresses allow for communication to occur between these hosts. Okay. Now, this IPv4 address, which I'm talking about, has a few unique properties to it, and you have to remember these properties. Firstly, your IPv4 address is a 32-bit address. What I mean by 32-bit is that it contains 32 zeros and ones consecutively. So a bit will either be equal to the value of 0 or it will be equal to the value of 1. Okay. And your IPv4 address is a combination of 32 bits. Okay. So it has 32 zeros and ones consecutively. Okay. And this entire 32-bit address is again divided in 4 equal parts, where each part consists of 8 bits, and that each portion of 8 bits is commonly known as an octet. Okay, octa usually represents 8. So your entire 32-bit address is divided in 4 parts of 8 bits each. Each of that 8-bit portion is called as an octet, and each octet is separated by a dot symbol. So if you notice, there are 8 bits here, 11000000. So these are 8 bits. Then you have a dot, then another 8 bits, then a dot, then another 8 bits, then a dot, and then another 8 bits. Okay. So this language of zeros and ones is commonly known as the binary language. Okay. And your computers or your information systems always at the core level communicate in binary language itself. Okay. So when one device is sending the data to the other device, at the first level, at the base level or the core level, the data is always transmitted in these signals of zeros and ones. Okay. So this is something that the computer very easily understands. Okay. But we humans find it a bit tough to understand binary language. What we regularly use in our day-to-day lives are decimal numbers, numbers from 0 to 9. So now I'm going to show you how do you convert any computer readable language like binary language into a human readable language, decimal language. Okay. So we learn how to convert a binary number to a human readable decimal number now. Okay. Now, before that, any questions or doubts up to this point? Understanding what IP address is, or what networking is, or what networks are, what are hosts, and what are the properties of an IPv4 address. Any questions, any doubts? Does anyone want me to repeat anything? Krishna, Mahinder, Pankaj, Shrija, Veera Prasad,
No, sir.
Harsh. Uh, Right. So let's talk about the conversion now, guys. So when you take this number 11000000, this is actually equal to 192. Okay. This number 10101000 is actually equal to 168. This number with all zeros is simply 0. And this number here with 00001010 is equal to 10. But how am I getting these values? How am I able to convert that? Is the main question. So let's talk about that. Okay. So to convert any binary number to a human readable decimal number, there are two very simple rules. So let's say if we take the example of this number here, 10101010. So there's an octet here with 8 bits. If you want to convert this octet of binary numbers into a human readable decimal number, first thing, you write down the values from 2 power 0 all the way up to 2 power 7 from right to left under each bit. So the rightmost bit will have 2 power 0, then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, 2 power 5, 2 power 6, and 2 power 7. So under each bit, you're writing down these values from right to left. Once those values are written, then you multiply the lower value with the top bit and you add it to the next one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. Okay. So no matter what the bit be on the top, no matter what the number be on the top, you just multiply the lower value with the top bit and you keep on adding it till the end. Okay. Now to understand this or to calculate this, let me write down the values of these numbers first. Anything to the power 0 is always equal to 1. It's a mathematical rule. Okay, so 2 power 0 is 1. 2 power 1 is 2 itself. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 120. So when I say 2 to the power of something, it means you multiply that number those many times. I think you might already know that. So 2 power 3 is something like 2 into 2 into 2, 3 times. That's 8. Okay. 2 power 5 is 5 times. 2 into 2 into 2 into 2 into 2. That's 32. Right. So now that you know these values, we can substitute it here. 2 power 0 into 0. How much is that? So 2 power 0 is 1. 1 into 0 is simply 0. Plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, that's 0. 2 power 3 into 1, 8. 2 power 4 into 0, 0. 2 power 5 into 1, 32. 2 power 6 into 0, 0. 2 power 7 into 1, 128. And if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans enter the number 170 on a computer, it understands it as 10101010. Okay, that sequence of frequencies. If you take 1 as high frequency and 0 as low, so that when that exact sequence of frequencies flows through a computer, high, low, high, low, high, low, high, low, it understands it as the number 170. Okay, that's how at the core level computers are communicating, and that's how you can convert that conversion of convert that number from a binary conversion to a decimal conversion. Okay. Is that clear, everyone? Any questions regarding this conversion? Because this is very important to understand IP addresses, guys. Okay. This conversion itself will give us the range of IP addresses. Okay. So any confusion regarding this conversion? Does anyone want me to explain it again? Please do not hesitate, guys. Might seem a bit complex. Okay. But again, it's easy if you ask me your questions. Okay. And if I clarify. Okay. So anyone who wants me to explain it again?
Sure, one quick question. Is
Yeah.
there any reason is there any reason like a 2 power 7 equals to 128 that he wrote on the last right one?
Mhm.
That
Yeah,
order
because
is
it's starting
reversal.
from 2 power 0 over here, Mahendra. Since it's starting from 2 power 0, for the eighth bit, you'll have 2 power 7 rather than 2 power 8. If it was starting from 2 power 1, it would have gone to 2 power 8. But if you remember, if it's starting from 2 power 0, the first value, That's why it's going up to 2 power 7.
Everyone understood, Shoaib. Like
Otherwise, if it's, yeah, go ahead.
So the
Hello.
Yeah, I can hear you, Mahendra. Go ahead.
Sir, this is Pankaj.
No, I think Mahendra was asking.
Hello.
right, Shoaib. So can you show the screen, Shoaib?
No, it's not visible. Oh, my bad. 1 second. Yeah.
So the first one, right? 2 power 7 equals 2. You wrote it as like 128 on the end of the line, right? So is there any reason? So the order is reversed, right?
Oh, yeah. Again, if you, 1 second, I think I can. 1 second. So if you remember, you're multiplying the lower number with the top one. So 2 power 0 into 0, I've written it on the left here, 0. Plus 2 power 1 into 1, that's 2. 2 power 2 into 0, that's 0. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0. 2 power 5 into 1, that's 32. 2 power 6 into 0, 0. 2 power 7 into 1. 2 power 7 is 128. So 128 into 1, that's 128. So again, it's over here, I've written it from left to right, although the calculation is from right to left. Maybe that is what might have caused the confusion for you. But I hope you are observing these values here. So I'm starting from left to right here. The statement is from left to right. Okay. So that's why there's 128 over here. Okay. And if anyone has a question, why specifically 2 power everywhere? This is a binary number. There are only 2 possibilities. That's why you have 2 power everything. 2 power 0, 2 power 1, all the way up to 2 power 7. Okay. Is that clear, Mahendra?
Yes, that's clear. Thank you.
Right. Yeah, Pankaj, you were saying. You had a question, Pankaj?
Sir, what about the local host? That is 127.0.0.1.
Yeah, that's a loopback IP. Don't skip ahead. We'll come to that also. So I've not talked about any IP address until now. We're still at decimal to binary conversion, okay? Or binary to decimal. So don't jump ahead. We'll talk about those also in the upcoming sessions, okay? No matter what IP you take, you'll be getting it from these numbers itself at the core level, okay? So now if everyone has understood this, guys, I have 2 more numbers here, okay? 0, 1, 0, 1, 0, 1, 0, 1, and all ones. And what I want you to do is, if you have a pen and a paper beside you, I want you to calculate these binary numbers and convert them to decimal and give me the answers for those. Okay. So the 2 numbers are 0, 1, 0, 1, 0, 1, 0, 1, and all ones. Okay. Take your time, no rush. You have the values here from 2 power 0 to 2 power 7. Convert these binary numbers to decimal numbers and give me the answers.
$85.
Okay, guys. So one answer given by one of the students is 85. Let's wait for the others also.
Yeah, it's 85.
I've got one answer as 85. Let's verify that. So 2 power 0 into 1, that's 1 itself. Plus 2 power 1 into 0, that's 0. Plus 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. And 2 power 7 into 0, 0. So if you add all that up, you get the number 85. Correct answer for the first one. Any answers for the next one, guys? All ones.
55.
55. You sure?
255.
255. Okay, so I've got one answer as 255. Let's wait for the other answers also. The second one, but oh, okay, right. Perfect answer, guys. Perfect answer, Harsh. So yeah, so the second one is 255, guys. So if you add all these up, so you have ones everywhere. So you just got to add everything up. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And when you add all that up, you get the number 255. Now you might have a question. Oh, why am I explaining all this? Why do we need this binary to decimal conversion? The reason is this conversion itself explains what the range of IP addresses are, guys. Okay. So if someone ever asks you what the range of IP addresses are and why are they specifically limited at that range, the understanding of binary to decimal conversion is important for that. So if I had to get the first IP, all I have to do is put simply zeros everywhere. In the first octet, all zeros. In the second octet, all zeros. In the third octet, all zeros. In the last octet, all zeros. Because that's the minimum value I can get. When I put all zeros, that's the least value I get, which is 0 dot 0 dot 0 dot 0. That's your first IP. And if I had to get the last IP, what would the solution for that be, guys? How do I get the last IP? Just by putting ones everywhere. That's the maximum number. Okay. So when I put all ones, you have given me the answer. It's 255. So the last IP in IPv4 range is 255.255.255.255. That's the last IP. So in your entire IPv4 range, you'll only have IP addresses ranging from 0000 to 255.255.255.255. You would never have IP addresses in the negatives lesser than 0 or in the positives above 255 or beyond 255. Whatever IP it be for any octet, it would only range from 0 to 55. And why is it limiting to 255? Because in an octet, when you put all ones, the maximum value you can get for converting that binary to decimal is 255, not more than that. Okay. And if someone asks you how many IPs are there in total, if you notice, each bit over here has two possibilities, 0 or 1. And there are a total of 32 bits. So in every bit, you have two possibilities. For 32 bits, you would have the possibilities of 2 raised to the power of 32. So that would give you a total of 4.3 billion IP addresses. So back then, when these were invented in the 1950s or so, they thought 4.3 billion IPs was a very large number. It would be sufficient for the rest of eternity. But that was a very wrong assumption. And they slowly started understanding that this would not be sufficient. They've shifted to IPv6. They've started creating a much more newer version of IP addresses, IPv6. And I'll explain that as we progress with our classes. Don't worry. But this is the entire number of IPs, 4.3 billion. Okay. Back then in 1950s, they were sufficient. You didn't have mobile phones back then. But fast forward to 2024 or 2025, sorry, the population itself is 8 billion people. And each person again has multiple devices. So these 4.3 billion IPs are again divided in various categories. There's something called classes. There's something called public IPs. There's something called private IPs. We'll discuss all of those. Don't worry. Okay. But how do you understand the sequence of these 4.3 billion IPs? We know what's the first IP. We know what's the last IP. What about the IPs in between? How is that sequence flowing? Let's talk about that today. Okay. So when you talk about the sequence of IPs also, there are two simple rules to understand the sequence, guys. To explain this, I'll take up a notepad file and explain it in that. Okay. So we know the first IP is 0000, right? So let me write it down. Yeah. Right. So we know the first IP is simply 0000. Now, if you had to get the next IP, rule number one is you always start incrementing from the rightmost octet. Always start incrementing from the rightmost octet. What I mean by that is if you have the first IP as 0000, next IP would be 0001. Rightmost octet increases by 1. Okay. Then you have 0002, then 0003, then 0004. This goes on all the way up to 000255. Now, after 000255, can I have a number like 000256? Is this possible by any chance? Do you think this number or this IP is a possibility, guys? Zero,
No,
zero,
sir.
zero, 56. Yeah,
No.
definitely not. Right. So once you reach the maximum number there, once the rightmost octet reaches to 255, then comes rule number 2. So once the rightmost octet reaches the maximum value, move to the left octet. Okay. So the rightmost octet cycles back to 0. So this 255 becomes 0 again. And the left octet now increases by 1. So after 000255, you have 0010. Now after 0010, don't directly jump to 0020. That would be wrong. Remember rule number 1, always increment the rightmost octet. So the 0 again changes to 1, then 2, then 3, then 4, then 5, goes up to 255. And then it cycles back to 0. And this 1 changes to 2. Okay, so if you see there's a pattern here, 00 to 0255, 10 to 1255, 20 to 2255. Again, I skipped a few IPs in between, don't worry. But I hope you're understanding the pattern. 30 to 3255, 40 to 4255, 50 to 5255. Like that, the pattern keeps on repeating. And down the line, you would have 2540 to 254, 255, 2550 to 255, 255. Now both these octets are filled. What happens next? They cycle back to zeros, and the next octet changes to 1. Okay. And you have again 00, the first set pattern. Okay. So whatever repeated here from 000 to 0255, same thing again repeats from 100 to 1255255. Okay. So again you have 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255. Like that, it goes on up to 2550 to 255255. And then it changes to 2. So same logic, same pattern. 200 goes up to 2255255. 300 goes up to 3255255. 400 goes up to 4255255. 500 goes up to 5255255. And like that, it goes on and on and on and on. And somewhere down the line, you would have 25500, which goes up to 255, 255, 255. Okay. Once all these three octets are full, the last octet now changes to 1. And whatever cycle repeated from 0000 up to 0255255255, same entire cycle repeats from 1000 all the way up to 1255255, then 2000 to 2255255255, 3000 to 3255255255. Like that, it goes on and on and on. And then you have 255000, and the last IP up to 255, 255, 255, 255. Okay, that is how the IPs are flowing in a sequence. And if you count each and individual IP one by one, you would have a total of 4.3 billion IP addresses, approximately. Okay, so that's the entire sequence of IPs, I would say. Okay. This is important. I'll explain why this is important in the upcoming sessions. Okay, but I hope everyone has understood the sequence. Any questions regarding the sequence, guys? Two simple rules. Rule number 1, always start incrementing from the rightmost octet. Rule number 2, after the rightmost octet reaches the maximum value, move to the left octet. As simple as that. Okay. Any questions? Krishna, Mahinder, Pankaj, Shrija, Veeraprasad, Harsh, Shreya, one second, Shweta, sorry, my bad. Any questions, anyone? Okay. Harsh, any questions? Krishna, any questions? Mahinder.
No, it please.
Harsh, you were saying something? Your voice got cut. There was. Harsh, there's a lot of static in your audio. I think there's an issue with your mic. I'm unable to hear you. There's a lot of static coming in. I think you can drop your question in the chat box, Harsh. I'll look into it. Yeah. Are there any questions, guys? Krishna, Mahinder, Pankaj, Shrija, Veera Prasad.
No questions. It is very clear.
Okay, perfect. So that's the sequence of IPs, guys. And again, as mentioned, this entire 4.3 billion IP addresses are divided in multiple categories. So there's first categorization called classes. And there are 5 classes: class A, class B, class C, class D, and class E. So your entire 4.3 billion IPs are divided in 5 classes first. And again, in each class, there's a subcategorization. Class A has 2 subcategories: public IPs and private IPs. Class B also follows the same order. It has some public IPs and some private IPs. And similarly, Class C also, public and private. Class D and Class E are exceptions. They do not have any private IPs in them. All of them are public IPs itself. Okay. So Class A, B, C have public and private IPs. Class D and E only have public IPs in them. Okay. So before we get into the classes part, let's talk about what public and private IPs are. Okay. And what is the difference in them. To understand public and private IPs, let's take the example of our home network. Okay. So in our home, we have a lot of different devices. So we usually have a Wi-Fi router, and to that Wi-Fi router, we have other devices connected. Let's say you have a laptop, a smartwatch, a smartphone, a smart TV, a smart speaker, whatnot. All of these devices here, guys, are your local network devices. Local networks are also commonly known as intranets. Okay. So each of these devices is your internal local network device. Okay. So when there's communication required in your internal local network devices, there you go for something called private IPs. So private IPs are the addresses which can be used locally in a local network to address and give identity to each device. Okay. In a closed local network. Okay. But when any of these devices wants to communicate with the internet, private IPs are not sufficient for that. You need a public IP. But where are you getting that public IP from? So if you notice, your router gets a cable from outside your house. Okay. It could be an optical fiber cable, an RJ45 cable, whatnot. Okay, a LAN cable, whatever. So there's a cable from outside your house coming and connecting to your router. That comes from something called the ISP, Internet Service Provider. So in India, we have ISPs like Act Fibernet, Airtel, Hathway, BSNL, Geo. All these are ISPs in India. In US, you have ISPs like Verizon, AT&T, T-Mobile, Mint Mobile. All of these are ISPs in US. Okay, so these ISPs hold something called public IPs, and they provide public IPs to their clients or customers to access the internet. Okay, so your router gets a cable from outside the house from the ISP, and that carries the public IP with it. Okay, and this public IP is shared to all the devices in your local network. So all of these collectively use one single public IP to access the internet. So if my phone wants to communicate with Google, it first sends the request from its private IP to the router's private IP. Router then transfers the packet from the private IP to the public IP that it receives. Okay. And with that public IP, it reaches the ISP. And from there, it travels across the internet, across multiple different servers, and reaches google.com with your unique public IP. Okay. So to define what public and private IPs are, public IP addresses are globally unique IP addresses, which are used to identify devices over the internet, the public internet. They are allocated by the internet service provider, and they are routable over the internet. So whenever you want to browse the internet, you always need a public IP for that. Private IP cannot connect to internet directly. Okay. And if you want to check what your public IP is, you can go to your browser, and in your browser, you can do a quick search, what is my IP? And that shows you your public IP. So this here is my public IP currently, 49.204.238.219. And if you carefully observe, all the numbers here are between the range 0 and 255. Okay. And if I click on this website, what is my IP address.com, it gives me extra detailed information as well. Who my ISP is and where is this IP being received from. So since I'm located in Visakhapatnam, Andhra Pradesh, that is where I'm getting the IP from. Okay, from my ISP. Okay. Now, if you want to talk about private IPs on the other hand, these are the IP addresses used within private networks. So in your home network, in your offices, in your organizations, when you want one device to communicate with the other in a local network without internet, there you go for private IPs. So these private IPs are not for accessing the internet. You cannot directly access internet with just a private IP. Okay. They only allow devices within the same local network to communicate with each other. So in a local Wi-Fi network, let's say in a local network or in a local wired network with your LAN cables and a switch, you can connect these devices with each other with a private IP. You can share files, you can send data, receive data in a local network using private IPs. Okay. And if you want to check what your private IP is for your system, if you're running a Windows system, open up your command prompt, CMD, and in the command prompt, run a command called ipconfig. Okay. And since I'm connected to my Wi-Fi network, wireless LAN, you can see this here is my private IP, 192.168.0.5. Now, why specifically is my private IP starting with 192.168? And why is my public IP starting with 49 dot something? Is because these are ranges allocated. So each public IP and each private IP in each class has a range allocated to it. Okay. So we'll discuss this range as well. Don't worry. Okay. Now, a much more important concept to understand. How are these 4.3 billion IPs being sufficient? Okay. So to understand this, guys, let me explain this with a very simple diagram. Okay. So, okay. So again, how are public and private IPs communicating with each other and how are these IPs being repeated? So if you remember, I've mentioned there are only 4.3 billion IP addresses. Okay. But the world itself contains 8 billion people. Okay. So some IPs here, which are basically your private IPs, can be repeated infinite number of times. Okay. Let me explain how. So let's assume here is my house. Okay. So this is my network here or my home network. Shoaib's home network. Okay. Now in my network, I have a Wi-Fi router here. Okay, the perimeter. And along with my Wi-Fi router, I have some other devices. Let's say I have some PCs over here, some smart TVs, okay, and a smartphone. Okay. So when any of these devices wants to communicate with each other in my local private network or my intranet, they use private IPs. So my router could get something like 192.168.0.1. My phone could be getting 192.168.0.2. Okay. Similarly, my laptop here could get 0.3. This could be 0.4. This could be 0.5, let's say. Okay. Now, when any of these devices wants to communicate with the internet, so let's say there's a website here, google.com, www.google.com. So if I want to communicate with Google, I need a public IP for that. So from my ISP here, Internet Service Provider here, let's say this is the ISP, and let's say this is something like Ed. Okay. Yeah, much better. Okay. So your ISP, again, my ISP, let's say, is going to provide me a public IP, something like 1.2.3.4, let's say. Okay. So when my phone wants to communicate with google.com, first it sends a packet to the router. Okay. So from here, it sends a packet to my router here with the private IP. So from 0.2, the packet is sent to 0.1. And then your router is capable of communicating across two different networks. So from 0.1, it shifts the packet to the public network to 1, 2, 3, 4. And with that public IP now, it reaches the ISP. Okay. So it now goes to the ISP here with that public IP. And from the ISP, it reaches google.com here with that public IP. So this connection that is happening here is happening on the public IP 1, 2, 3, 4. Okay. Now let's say there's another network here. Okay. Let's say there is Harsh's network or who else? Yeah, let's say there's Pankaj's network or someone else's network. Okay. So there's one more home here. Okay. Let's call this Pankaj home network. Okay. So now at Pankaj's home also there's a Wi-Fi router. Okay. Along with the Wi-Fi router, he has his own personal devices as well. Okay. Like some mobile phones, laptops. Sorry. Let's say there are two devices here. Okay. One more device here. One more phone here. Okay. So again, in his network also, guys, we could actually repeat the same private IPs. So something like 192.168.0.1, 192.168.0.2, 192.168.0.3. 192.168.0.4 and 192.168.0.5. Okay. Now you might have a question. How is this possible? How does Pankaj's home network and my home network have the same IPs? Okay. The reason being, guys, there is no direct connection between my home network and Pankaj's home network. As our networks, we are two different entities altogether. Okay. There is no connection between us. If I had to communicate to google.com from my phone, and if Pankaj had to communicate with google.com from his phone, the connection doesn't happen on our private IPs, guys. It happens on the public IP. So again, Pankaj is also connected to the ISP and he gets his own public IP, a unique public IP for him. So let's say he gets something like 2345. Okay. So when Pankaj's phone wants to communicate with Google, firstly, it sends the packet from here, from his phone to the router. So from 0.5, it goes to 0.1. Okay. So let's say my phone is also 0.5. Let's call this 0.5 here. Okay. And even Pankaj's phone is 0.5. Let's say. Okay. Then Pankaj's phone's packet now goes from the router to the ISP. Okay. So from the router's private interface, it goes to the public IP interface. From there, it reaches the ISP. And from there, it connects to Google. So when his packet is coming to Google, guys, that packet will always hold the private IP as the public IP as the address, not the private IP. So when my packet from my phone is going to Google, it will hold the IP 1234. That's how it recognizes my phone. Okay. And when Pankaj's phone is communicating with Google, it will have the address as 2345, Pankaj's public IP rather than his private IP. So whenever there's traffic on the internet, guys, that internet traffic is always based on your unique public IP. Okay. And when you talk about private IPs, they are only for your local network. So as many homes as you have, even if you have 1,000,000 homes, in all those 1,000,000 homes which are not connected with each other, you can use the same private IPs. You can repeat the private IPs infinite number of times. Okay. So that is how these 4.3 billion IPs are still sufficient today, although we have such a huge population with such huge number of devices. Okay. When this would have a problem is if the public IPs are exhausted. So in that scenario, you have to completely shift to private IPs because public IPs cannot be reused this way. They're pretty unique. Okay. Private IPs, on the other hand, can be reused as many times as you want. Okay, in different places. Okay. So it's like two people having the same name. Okay. So there could be a Shoaib in my home. There could be a Shoaib in other places or another home as well. What will be same as our first name? Okay, what will be differentiated on is our surname. I could be Muhammad Shoaib, and there could be another person called Shoaib Akhtar. Okay, so the surname there is something like the public IP. Okay, the first name is like the private IP. Two Shoaibs, okay, two same names, but the surname is changed. Okay, that is what gives identity from one family to the other family. Okay, even though you have the same name as the first name, right? Is that clear, guys? Everyone, any questions or doubts up to this point? What are public IPs? What are private IPs? How we are repeating these private IPs in two different networks? Okay, and how public IPs are unique? Any questions? Any doubts up to this point? Anyone? Shweta, Harsh, Krishna, Mahinder, Pankaj, Raj, Srija, Veera Prasad. I'm trying to explain this in the simplest way possible, guys. But even then, if you have a question, please do not hesitate to let me know. I'll try to find better examples. I'll try to explain it in a much simpler way. That is my responsibility. Okay. What I want you to do, or how I want you to be responsible is by asking questions. You're paying for this. You get most out of it. Okay. Do not hesitate to ask questions. Oh yeah, Shweta, using something. Oh, okay. Thank you, Shweta. Others, guys, Mahinder, any questions? Pankaj, any questions? Raj, Shrija, Veera Prasad. Please do
No,
ask.
it is clear actually. There is no question.
Okay, perfect, perfect. So yeah, we'll keep the session short for today, guys. This is our first class on networking fundamentals. What we have covered today from the very first topic is we have covered what networking is, what are networks, what are hosts, again, what are IP addresses, IPv4 addresses, what are the properties of IPv4 addresses, how do you convert a binary number to a decimal number, and this conversion allowed us to understand what's the range of IPs, what's the first IP, what's the last IP. Then we talked about the sequence of IPs, How are the IPs progressing one after the other? Then we talked about public and private IPs today. Okay, what are public IPs? What are private IPs? Where do you use which category of IPs? So in local networks, you go for private IPs. On the internet, you go for public IPs. Okay. Tomorrow, we're going to discuss a lot more in depth where we talk about these classes. So what is class A? What is class B? What is class C? What is class D? Okay. We'll talk about all this in the session tomorrow. Okay. And one more thing, guys, if this timing is not suitable for you, if the morning session is not suitable, there are batches in the evening as well. So in my evening at 7 p.m. and at 8:30 also, there are two batches running simultaneously. So if anyone is interested in the evening batch, you can join at the evening batch. So for them also, I've completed only the first class up to this exact point. So if anyone is interested in the evening batch, you can let them know. Okay. Right. Yeah. What is your time zone again, Shweta? London. Right. So in my evenings, which is my 7 p.m., that should be your 2:30 in the afternoon. So currently it's 8. So sorry. Oh, it shows 4:13 a.m. What did you say? Arizona. I heard as London time. My bad, my bad. Arizona would be EST. I'm not wrong. Okay, let's try this. So it's 8:14 for you in the evening right now, in the night. Okay, perfect. So my 7 p.m. should be your 6:30 in the morning. If that is too early, there's one more batch at 8:30, my 8:30, which is 8 a.m. your morning. So those are the two time slots available. So others also, guys, if morning time is not suitable for you from the other institute, as mentioned, there are two other batches running as well. One is at 7 p.m. and one is at 8:30 p.m. I think someone yesterday requested to the institute that morning times are not a bit feasible. So whoever is feasible with morning, you can run in the morning session. If morning doesn't work out for you, there are two evening slots as well. You can confirm with the institute. Okay. Harsh, is this timing suitable for you, or do you want to shift to a different timing? Yes. Okay. Right, 11:15. So in the evening, that would be, so my evening is, so you have one more batch at 9:30 in your morning or 11 a.m. your morning. So those are the two other available slots. So there's one batch in my morning, which is your 10:30 in the night. And there are two other batches one at 9:30 in your morning and one at 11 a.m. in your morning. So whichever is suitable for you, you can join in any one of those batches. There are three batches running simultaneously. Okay, so you do give me a confirmation though, Harsh, if you're planning on joining my evening sessions, which are your morning sessions. Okay, and I'll let the institute know as well. Okay, and yeah, thank you guys. And if yeah, that's that. Nothing further, guys, for the session today. Please do connect back tomorrow. We'll continue on what these classes are. We'll talk about the range of classes and we'll talk about the relevance of these classes. What is class A? What is class B? What is class C? And some important protocols. What is DHCP protocol? What is DNS protocol? A lot more interesting concepts and a lot more in-depth concepts on networking. So we'll complete all this in the next session. Okay. So yeah, that's that. Nothing further. We can exit the session and connect back tomorrow at the same time. Bye-bye. Thank you guys. Bye.